Ever stop to think about how, with literally billions of devices online, a video from a server halfway across the world finds its way to your specific phone in just seconds? Well, it's all thanks to a system of digital addresses. And today, we're going to break down the OG system that still runs so much of the web, IPv4.
I mean, it really feels like magic, doesn't it? You click a link and poof, the page just appears. But behind that simple click, there's this incredibly elegant system, making sure all those little packets of data navigate the huge maze of the internet right to your screen. So let's pull back the curtain and see how it really works. You know, the easiest way to wrap your head around an IP address is to think of it just like a postal address for your house. Your laptop, your phone, they each have a unique address. So when you ask for a web page, you're basically sending a letter to that website server, and it needs your return address to send the data back. Without these, the internet would just be pure chaos. Okay, so what do these digital addresses actually look like? Are they just a random jumble of numbers? Nope, not at all. There's a really cool structure to them, a kind of hidden language that computers understand perfectly. Let's decode it together. You've probably seen this before, right? 4 numbers, each separated by a dot. This is what we call dotted decimal notation. And really, it's just a convenient way for us humans to read and write these things. But to a computer, this is like a foreign language. It sees the world in a much, much simpler way.
See, deep down, computers are pretty simple. They don't get words or numbers like we do. Their entire universe is built on a language that only has 2 characters, a 0 and a 1. Think of it like a light switch. It's either off, that's a 0, or it's on, that's a 1. To really get how IP addresses work, we gotta learn to speak a little binary.
So that IP address is really just a long string of 32 ones and zeros. Now, that's a lot to look at all at once. So to make it easier, we break it down into 4 manageable chunks of 8 bits each, and each of these 8-bit chunks has a special name, an octet. These are the basic building blocks. And this is where the magic happens, turning those ones and zeros into numbers we actually recognize. It's all about place value. In an 8-bit octet, every position represents a power of 2. So starting from the right, you have the ones place, then 2, 4, 8, 16, and so on, all the way up to 128. It's like having a set of 8 light switches, each with a different value.
The conversion is actually super simple. You just add up the values for any position where you see a 1, where the switch is on. If a position has a 0, you just ignore it. So for example, if the binary is 11000000, you just add the value for the first 2 spots, 128 plus 64. And that gives you 192. Easy as that.
And there it is, the dotted decimal address we started with, 192.168.1.254. It's nothing more than a human-friendly translation of this long 32-bit binary number. Each of those 4 numbers is just the decimal version of its 8-bit binary chunk. It's a really elegant system when you see it all laid out. Okay, so now that we know what an IP address is, let's talk about what it does. It's more than just a unique ID for your computer. It also tells us where your computer lives on the internet. It's like our postal address again, which has 2 parts, the neighborhood and the specific house number. Let's go right back to that postal analogy. The first part of an IP address is the network portion. You can think of this as the city and the street name. It gets the data to the right digital neighborhood. The second part is the host portion. That's the house number. It pinpoints the exact device on that street. Check out this diagram. It lays it all out perfectly. See how all the devices on this little network share the same network part, the 192.168.1? That's their digital street name. What makes each one unique is the host part, that very last number. This is how all the devices in your house can talk to each other. So we have these digital neighborhoods, but how big are they? Can a network have just a handful of houses, or can it have millions? Well, the answer comes from something called address classes. It was one of the early systems for creating networks of all different sizes. You can tell the class of an IP address just by looking at its very first number. Class A addresses, those start with a number from 0 to 127, are the absolute behemoths of the internet. They can support millions of devices. Then you've got Class B, the medium-sized networks. And finally, Class C, the small, cozy neighborhoods that are perfect for our home networks. So if you ever see an IP address that starts with something like 10 or 12, you are looking at a Class A network. These were given out to huge global organizations back in the day. Because only the first octet is for the network, the other 3 are for hosts. That allows for a staggering 16 million devices on just one network. Now, if an address starts with, say, 154, that's a Class B. Here, the first two parts define the network, which leaves two parts for all the devices. This gives you over 65,000 possible host addresses, which is great for a big university or a large company.
And finally, Class C. This is probably the one you're most familiar with. If your home Wi-Fi address starts with 192, you're on a Class C network. Here, the first three parts are in the network, leaving just the last part for your devices. This gives you 254 available addresses for your laptop, your phone, your smart TV, all that stuff.
So we've got these different network sizes, and each has a bunch of available addresses. But here's a little secret. You can't actually use all of them for your devices. A few are reserved for special jobs, kind of like the mayor and the town crier of our digital neighborhood. The first reserved address is called the network address. This is the one where all the host bits are zeros. Think of it as the official address for the entire street, not for any single house. It's just a way to refer to the whole network at once, which is why you can't assign it to your laptop. Then you have the very last address in the range, where all the host bits are ones. That's the broadcast address. This is basically the network's megaphone. When you send a message to this address, it's like shouting, "Hey everyone." That message goes to every single device on that network, all at the same time.
Okay, now this one is really cool. The loopback address, 127.0.0.1, is like your computer talking to itself in a mirror. When you send a message here, it doesn't go out to the internet at all. It just loops right back to your own machine. It's a super clever way for developers to test networking software without even being connected to a real network. All right, let's do a quick lightning round recap. We've learned that IPv4 addresses are really 32-bit binary numbers that we dress up in that human-friendly dotted decimal format. They have a two-part structure, the network portion, which is the street, and the host portion, the house number. We also saw how address classes create different size networks and how some special addresses have very important jobs.
But that leaves us with a huge question, a million-dollar question really. The entire IPv4 system only has room for about 4.3 billion unique addresses. Now that sounds like a lot, but think about it. We have way more than 4.3 billion devices in the world today. So how is the internet still working? How have we not completely run out of addresses? Well, that is a fantastic puzzle for another explainer. If you're curious about the answer and you want to join us for more deep dives into the tech that shapes our world, make sure you hit that like button and subscribe. It really helps us create more content like this. We've got so much more to explore together. Thanks for watching.